Good day, learners. You are welcome to today's lesson. And then today's lesson is just a recap of some of the concepts that we have learned, and then so that you will be able to answer the questions that you will be doing uh, at home. But I learned by the end of this lesson, then the host will share the link with you. So I'm not sure because in the other lesson the host shared the link, but I hope here too is going to be the same. All right. So let's go for it. Uh, so as I said, we are going to recap, and by the end of the lesson, you should be able to understand some of the concepts and be able to answer uh, all the questions or most of the questions that you are going to write. All right. All right, so let's go on. By the end of the lesson, so I've already told you that you should be able to define pure substance, least pure substance, the subatomic particles, and uh, other things. Now let's look. We started with this, and then we said atoms are simply what the basic blocks of what matter. So we said everything in the universe is made up of what matter. Matter is everything or anything that has mass and can occupy space. All matter is made up of what tiny particles called atoms. An atom is the smallest particle of matter that can exist on its own. Atoms cannot be destroyed or created. Not all atoms are the same. Anything that is made up of only one kind of atom is called an element. So take note of this. You might see something like this. I'm not sure. But all these definitions or concepts, you must take note of them. The atoms of some elements exist what individually. The atoms of some elements combine to form what diatomic molecules. So what it means is that some can be single, some can be double. Single atoms means they don't want to combine or they cannot combine because of certain things, and then double because they are easily combined. But those ones that are single, it means it's not easy for them to combine. So all the objects we see, the food we eat, the air that we breathe, and even our bodies are all examples of what matter. Matter is the name given to anything that has mass and takes up space, just like point two. All right. Now, as we said, anything around the earth, whether living or non-living, is matter. Although objects look smooth, they are made up of what certain atoms. All right, whether it's rough, it's smooth, it's made up of matter. And we said we cannot see atoms because they are too small. And we said we can only see atoms when they are enough together in one place. And even we have to use a microscope. So what this point is saying is that atoms are very, 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 very minute. And when you put them together, like in the form of a heap, our naked eyes cannot even see them. Then we have to be assisted with what a microscope. Then we are told that a single grain of salt contains what 1 trillion, a trillion atoms. The word atom simply means indivisible, which means that an atom cannot be cut into what smaller pieces. All right. Now take note. We also looked at the periodic table under the atomic or under the building block of matter. All right. And we said the periodic table atoms of one element are different from atoms of another element. But we said the periodic table contains the what element. So, and atoms of one element on the periodic table is different from atoms of another element. And then we look at, sorry, so when we look at the periodic table, for example, copper will be different from zinc. Okay, even though they are different from each other, but they are made up of atoms of the same kind. So copper, zinc, atoms of zinc. Okay, then we said the atoms of the noble gases exist individually. So, for example, what are the noble gases? If you check from the periodic table on your far right, you have 18. Group 8, you have helium, neon, argon, krypton, xenon, and random. All right. So all these ones that looks like yellow are what atoms of the noble gases or the inert gases. All right. Then the atoms, so remember they don't combine. You see that they are helium is just helium. It's not helium H2, neon E2, argon RaR2. No, they are the atoms that exist individually. They exist alone. But atoms of other elements such as hydrogen, oxygen, and nitrogen combine to form what diatomic molecules. So that's why we can see hydrogen 2, oxygen 2, nitrogen 2. Okay, so when you see hydrogen 2, it means hydrogen gas or hydrogen molecule. So it's diatomic. Diatomic means di means two, atomic. Diatomic, it means two atoms of hydrogen. I hope you get that. Now, when we look at atoms of helium, let's look at this figure that is 8. It's just written 8 there. You see that these atoms are single. Then these ones, when you see them, they are what? Diatomic molecules. So they are paired. So you take note. So these helium atoms, they don't want to be like what? The oxygen atoms. So that's why they are what? Single. Then we also looked at what the subatomic what? Particles. The subatomic particles. And then we said every atom has what? Compositions or and then so when we talk of the subatomic particles, the subatoms are the what? The atom and the electrons. All right. Now, this is a model for representing what? Yeah, is there a question here? Yes. Lemo. The test is today. The test is today. So I can see that you are asking when is the test. So please, the test is today. Yeah, so I hope it is. So at the end of this lesson, a link will be sent to you. So today is 21. On the timetable, the link, the test is supposed to be today. But you will do the test at home. A link will be sent to you so that you will access the link and do the test at home. I hope this will be in order so that we can continue. Okay. Now, so as I was saying, that the picture we are seeing is what the subatomic particles representing. So let me just quickly say this. The following picture of the atom show how they are all fit together. These three subatomic particles form the basis of what our modern day understanding of what atoms look like on the inside. Let's look at what is known as what each. Let's look at what is known about each particle in 10. So meaning we have got a nucleus, and as you can see inside the nucleus, we have got what? Protons and neutrons. And outside the nucleus, you can see these things that look like dash or dash. They are what? The electrons. So the electrons are basically moving around the what? The nucleus. So let's go on. Point two, the protons and neutrons are situated in the nucleus of the atom. The nucleus is at the center of the atom. The electrons move around the atom. The protons are positively charged. The neutrons are neutral and have no charge. The electrons are negatively charged. And a neutral atom has the same number of positive and negative charges. Now, if you get this one, let's go back to the diagram and then look at point 8. Point 8 is saying a neutral atom has the same number of positive and negative charges. So what it means is that if we go to this diagram and then we're going to check, let's count the protons, those ones that are plus. You can see that we count 1, 2, 3, 4, 5, 6, 7. So we have got what, 7. Let's count again. 1, I can see 1 here, 2, 3, 4, 5, 6, 7. Very good. So the protons are 7. Now let's count these ones that don't have anything. We have got 1, 2, 3, 4, 5, 6, 7. Very good. So what it means is that the number of protons are equal to the number of what? Neutrons here. Now let's also count the electrons. Outside we have 1, 2, 3, 4, 5, 6, 7. So you see that the number of electrons are the same thing as well the number of protons. Okay, I can see some questions here. I'm not sure of the time. Lisady and Helen, I'm not sure of the time, so I cannot confirm that. But I can confirm later when we're about to end the lesson for you. All right. Okay, so let's go on. So when they say an atom is neutral, what it means is that the positive and the negative charges are the same. So they remember the protons are what? Carrying positive, so they are positive charges. And the electrons are negative, so they are what? Negative charges. So when the negative charges cancel out the positive charges, then we say the atom is neutral. All right, so basically this slide is talking about what the subatomic particles. So you need to know the subatomic particles. What are they? The protons, the neutrons, and the electrons. And then you need to know what the charges. So proton, the charge is positive. Electron, the charge is negative. Neutron, the charge is 0 or neutral. Then we also need to know that what is a neutral atom. A neutral atom is an atom having the same number of positive and negative charges. Very good. I hope you got me there. Now, if you are following, answer this question. Write down the 3 subatomic particles with their charges. Let's do that. If you are following, just do this. I'm saying write down the 3 subatomic particles with their charges. So let's be fast. Send in your comments in terms of your answers. I repeat, and then I said, if you are listening, write down the subatomic particles and then also with their charges. That's what I just said. So let's quickly do that. Let's quickly do that. Send in your answers, my dear learners, so that we can continue. Yeah, I'm waiting for your answers. So let's keep the answers coming. All right, I'm waiting. Send in. So the question is, what are the subatomic particles? And then you also give their charges. All right, let's keep going. I'm not seeing or getting any response. I hope you'll heard me well. Okay. All right. Yeah, I have one here. Who is that? Okay, very good. Let's say the protons. Yeah. They say they try to send me a private, so you should send it to everyone people can see. So protons, positive charges, neutrons, no charges, electrons, negative charges. That is perfect. All right. I wish I can get another one. I wish I can get another reply from other learners so that we can proceed. All right, let me see. Who is that? Come. Okay, protons, positive charges. That's okay. Neutrons, no charges or neutral, and electrons, negative charges. That's very, very fantastic. Okay, keep it up. That's good. Okay, the next slide. Now, so we're basically going to explain what is happening here. How do we know what an atom looks like when we cannot see it? Even with the strongest microscope, scientists have developed a model of the atom based on the results a, of experiment that they did on the behavior of atoms. All right. Another point is saying that an atom consists of protons, neutrons, and electrons. And they cannot exist on their own. So take note. So the protons, neutrons, and electrons come together. They come together to complement, but each one cannot exist on their own or on its own. That's what point B is saying. Now, the positively charged particles called protons and electrically neutral charged particles called neutrons are tightly packed in the nucleus. The nucleus has an overall positive charge, and protons and neutrons together are called nucleons. So, listen to this question. What is the overall charge of the nucleus? What is the overall charge of the nucleus? Yes. What is the overall charge of the nucleus? I'm waiting for your answers. What is the overall charge of the nucleus? What is the overall charge of the nucleus? If you were listening, just send fantastic. Very it says that I said the overall charge of the nucleus. Somebody got it right. The overall charge of the nucleus is positive. Now, see, uh, why is the overall charge of the nucleus positive? You remember in the nucleus, we have got the protons and then the neutrons. And then the protons are positively charged. And then the neutrons are what? No charge. So positive plus zero will give me what? Positive. So that's why the overall charge in nucleus is positive. I hope you get that. Exactly and equal. So the electron, but we are talking about what? the proton. So the proton will have a positive charge. Okay. All right. I'm happy you having an idea about what I'm talking about here, and which is good. All right, let's continue. The nucleus is a positively charged sphere in the center of the atom. It consists of a positively charged protons and neutral nucleus and neutral neutrons rather. The electrons move at very high speeds in orbit around the nucleus. They form an electron cloud that is much larger than the nucleus. Atoms are neutral because the number of negatively charged electrons is equal to the number of positively charged protons. The overall charge of an atom is zero. The overall charge of an atom is zero. All right. What do we mean by that? When they say the overall charge of an atom is zero, what does that mean? Leonard, I'm posing this question for you. Can you make me when they say the overall, yes, the overall of an atom is zero? What does that mean? Okay, let me see. It means no charges. Okay, I can see the sun. The sun. All right. Now it's true. It means they have no charges. Now, have you heard of this? Of this? Let me send it to you. Let me send it. Have you heard of this ion? Have you heard of this term ion? Have have you heard of the word ions? Yes, I've just asked a question. Have you heard of the word ions? IONS. Yes, is for everyone or is to everyone. Have you heard of the word ion? Come back to me if you heard of it. Have you heard of that? Okay. Yes. Daniel said yes. Okay. All right. Now let me explain. Okay. Quickly, I can see you also said yes. Let's say yes. Okay. I think it's only the son who is saying no. Okay. Let me try to explain it so that listen and other people. All right. Now, when they say the overall charge of an atom is zero, it means that the atom has not gained or not lost. So that word I asked you whether you have seen it before, IONS, means ions. Some call it ions, but ions. So what is an ion? An ion is a positively charged or a negatively charged particle. Now see, if an atom loses an electron, then it becomes what? A metal. But immediately that atom gains, when it gains, then it becomes what? Cations. So when an atom loses, it's carrying 1 plus. When an atom gains, it is carrying 1. And when it gains, it is carrying what? Minus. Okay. All right. Let me see. Someone send something here. Yeah, okay. Fantastic. Yes. Income. Exactly what I'm saying. That's great. That's great. Yes. An atom or molecule with a net electric charge due to the loss or gain of one or more electrons. Perfect. So if the atom gains an electron, it's going to be minus. It's going to be minus. And when it loses, it's going to be what? Positive. So if it loses, so mostly take note of this. Mostly Metal loses. Metals, they lose electrons. And non-metal, they gain electrons. Now listen to this and don't be confused. Don't confuse or don't be confused with these signs. In mathematics, when we talk of plus, we're talking of what? Adding. And we talk of minus, we're talking of what? Subtracting, taking something out. But the opposite is true in chemistry when we're talking of what? Ions. In chemistry, if you see an atom carrying plus, it means it has lost an electron. So for example, if I have x raised to the power plus 1, it means it has lost a what? An electron. I hope you get that right. And if it gains, instead of being plus, here is minus. So take note. Plus means losing and negative means gaining when we're talking of what? Ions. So take note, don't be confused. Now, the next point says that the simplest atom in a hydrogen atom, the simplest atom is the hydrogen atom. It has only one proton and one electron and no neutrons. So if you look at the periodic table, the first element on top and the left-hand corner is the what? Hydrogen atom. A carbon atom has 6 protons, 6 neutrons, and 6 electrons. Perfect. So now let us look at the last document, the last point, and I want you to answer this. What term do we give to a carbon atom that has 6 protons, 6 neutrons, and 6 electrons? What term do we do to that, or do we give to them when an element has got everything being equal? Yes, the last point. The last point says a carbon atom has 6 protons, 6 neutrons, and 6 electrons. My question is, what term do we give to that when an atom has got everything being equal? The protons are equal, the neutrons are equal, and then the neutrons are also equal. Yes, the clock is ticking. I'm waiting. The clock is ticking. The clock is ticking, the clock is ticking, the clock is ticking, the clock is ticking, the clock is ticking. Guys, Lena, send in your answer. The clock is ticking. The clock is ticking, the clock is ticking. The clock is ticking, the clock is ticking, the clock is ticking. Oh, we call it, you're still waiting, and let me give you the answer. We call it a neutral atom. Okay. When the number of protons are equal to the number of electrons, we call it one the neutral atoms. All right, let's go to the next. All right. Now, you remember previously we also looked at what pure substances, and we said pure substances are substances consisting of what? Only one kind of atom or molecule. Examples of pure substances are elements and compounds. Take note. Examples of pure substances are elements and compounds. So let's look at this diagram. Let's look at this diagram. All right. There are only 2 classes of pure substances, namely elements and compounds. To understand the difference between the two, let's look at this diagram below. So we are looking at what? Elements and compounds. An element consists of what? Atoms that are of the same kind. So let's look at this diagram. You can see that it's purple. You can see that it's purple. You can see that it's purple, and this is what is a compound because you have got other things here. So we have got a compound consisting of two or more kinds of atoms in a fixed ratio. Okay, so you see that the elements are just the same, purple. The compounds are also the same. It consists of two or more. So since we don't have other compounds or elements or substances mixed up with these, then it's a pure compound. So when we say a compound is pure, we are saying that it exists in certain manner in a fixed ratio. So the ratio of this is 2:1, hydrogen and what? Oxygen. All right, so let's go on. A pure substance cannot be seen with the naked eye. The atoms or molecules that a substance consists of determine whether a substance is pure. All right, so a substance is pure when it consists of only one type of molecule or atom. There are only two classes of pure substances. We call them elements and compounds. All the other substances are not considered pure substances. Okay, substances may look pure, but we can only know whether they are pure when we look at the particles that they consist of. Um, Leonard, what are you trying to say here? Oh, you are asking no code. This site there was, I don't know whether my place there was no light on, but I don't know whether it was a load shedding or whatever. So when the light came, I had to quickly join in. So if we are going to do Kahoot, it's going to take me a lot of time trying to switch on to Kahoot. I always leave them activated, but it means I have to go on. So I just started hurriedly. I didn't prepare everything. All right. Yeah, so we are revising for this test. So even if we are not able to do the code, I apologize and then I will always make it up to you. Né? All right. I know that you have started enjoying Kahoot. But as time goes on, I'm going to introduce another one for you, Edmondo. There is another one called Edmondo. So don't worry, Kahoot, I will make sure that you enjoy the assessment using the technology platforms. So just feel free. It's Edmondo. Edmondo is also another platform in which I will prepare everything, give you the code, you go and log in, and then you answer everything there. Yes, it's like that. So, but for now, let's just continue. Uh, so let's go. All right. Now, we have got this. So this is a task that talks about what? Water molecule, we have carbon dioxide molecule, we have got hydrogen molecule. All right. So here, water, there is a weight and is H2O. Carbon dioxide is CO2 and hydrogen is H2. So you see, now when people talk about pure substances, what do they usually mean? It usually means that substances without what impurities. Okay. So do you think water that is pure in a glass, do you think if we have a glass of water, and will you just jump into conclusion that the water is pure without taking into consideration the source? Yes. Now, if you do that, your answer will be wrong. So we can determine the source of the water to say or to make a conclusion or judgment to say is pure or not pure. Let's talk about distilled water. Distilled water, it means it's only water, H2O. There are no other impurities or dissolved ions there. But when we talk of tap water has got some other issues or impurities, hence it's not pure. All right. Okay. So when we're talking of pure water, pure water is pure. It means there are no other substances dissolved in it. Now, so let's go on. The table salt, sodium chloride. We remember the common name for sodium chloride is table salt, the one that we mostly use in the kitchen. Now, because of understanding sake, for the sake of understanding, they use cycles to represent them. Okay, and then sodium chloride will react in a ratio of what 1:1. What it means is that before sodium chloride will be formed, then we have got what? One atom of sodium and then one atom of what? Chlorine. So take note. All right. Then let's go to the next. So we have below are substances. So you see that it's water molecules, carbon dioxide molecules, and hydrogen molecules, nothing else. So when something is pure because it's made up of what? That substance only. The elements making up the substance in a certain fixed ratio. For example, if we're looking at water, it's H2O, meaning two atoms of hydrogen, one atom of oxygen. Carbon dioxide, one atom of carbon and two atoms of oxygen. And hydrogen molecules, just hydrogen molecules and nothing else. All right. Then we also looked at the periodic table, and then we say in the periodic table is basically contains metals, and then some are non-metals, some are metals, and between the metals and the non-metals, we have what is called the what? Semi-metals or the metalloids. All right. So you can see this pink and yellow. The yellow is indicating the non-metals, and then the pink is indicating the metals. And this light green between the pink, yeah, and then the yellow, we have got this one, which is talking about what? The metal or semi-metals. Okay. All right. So if you have any question, you can ask. Uh, if you have any question, you can ask in relation to the test. So I learned the link. Uh, I'm just communicating to get to find out whether the link will be sent to you. So ask any questions, and then I will turn to you. I'm waiting. Any question with regards to the assessment? Yes, keep them coming. All right, so let me quickly see. Yes, Daniel, the link is not with me, it's with the host. So I just sent her a message to find out. So she will do that. All right, so I'm not sure. So the link, I'm not the one who is going to send the link. It's going to be my host. And then I'm sure she will do that. So just bear with me. Yeah, how was the math test? Homolemo, why was the math test? You logged in and you did the assessment, ne? Yes, I hope it's going to be the same thing. Yes, so this one, the natural science test is also going to be the same thing. Okay, all right. So any other questions? Hello, sir. Okay, Leonard, I learned you can, the same way you did the same way you did for the physical sciences also. I'm told that we don't send the link. So please, the same way you access the link to mathematics, you do the same thing. Okay. So guys, learners, enjoy the rest of your day, and then uh, tomorrow when we are revising, you will get two tasks. All right. Cheers and enjoy the rest of your day. And bye for now.